Okay, good morning, students. So we were discussing in the last class with respect to the higher order procedures. So first of all, what is meant by higher order procedure? The procedure which can the procedure in which the arguments which you can pass can be where you can pass the name of the procedure. That means as an argument, if you are able to pass a procedure and if you are able to do the manipulation onto the procedures, then we can call those type of procedures to be as higher order procedure. Or we can even consider a procedure which returns another procedure that also can be considered to be as higher order procedure. So that is like if a procedure can return a procedure or a procedure can accept a procedure can be called to be as higher order procedures. So for explaining that, we have taken up this example where three procedures, three same pattern procedures we have defined, and we could define a common procedure. Excuse me. We could define a common procedure from this. So in other terms, I can say like wherever there is a small difference, there I have made it to be as a procedure. Say if you see here in this particular procedure itself, that is sum of integers, sum of cubes, pi sum, where wherever there is a similar contents, that we have mentioned it as such, but wherever there is a small change, we try to incorporate the procedure and we try to make it to be as a procedure call over there. So if you see here directly A we were using it. Here we are applying Q procedure onto this A. Here we are having some expression. So we have converted this to be as a procedure. So that a name of the procedure we can pass and we can call by passing the same some value of A. And again we are calling the same procedure. So the whatever new procedure we have given, that same new procedure we are calling it, where what was your in which where we have to get the next A value. So next A value we have defined it with respect to the next. So in terms of next, we have your A should be incremented by how many times or decremented by how many times. That we can define it and we can pass the name of that procedure over here. And we can apply it onto the value of A. So this procedure, we have defined an higher order procedure called sum, where you are passing two arguments, that is term and next is going to accept the name of the procedure, where A and B are going to take the value of it. Variables will be accepting the values. So now now you should be clear, like in this Lisp language, you can define a procedure where the arguments can accept values as well as the procedures as an argument values. So keeping that, we have defined one procedure explained with respect to sum of cubes. So this we have seen in the last class. So where we can directly call the sum procedure, which is already having by which we have already defined sum of finding the summation. So what for the summation series, we have already defined a procedure called sum. So by using this, which all procedures we can use, which all procedures can use this. So it is like sum of cubes. So already cube procedure we have defined, and A should be incremented by 1. So we have defined another procedure called INC, and we have directly called sum procedure, where we are just passing the term as an cube procedure, because cube has to be applied onto each A value. And next time, what should be your A value? It should be incremented by 1. So the name of the procedure INC has been passed as an argument for the sum procedure. And A and B values will remain same, what we are passing it for the sum of cubes. So those two will be the values. So similarly, we have seen with respect to pi sum, that is summation series. So in which we have defined inside this pi sum, we had to calculate 1 by 1.0 divided by x multiplied by x plus 2. So in a prefix notation, we could write it in this way. So for calculating this content, we have defined a procedure called PyTerm, where it accepts one argument, which is x. After that, what should be your next x value? Next x value should be incremented by 4 times. So for that purpose, we have defined an PyNext procedure where you're accepting the x value and x is getting incremented by 4 times. So now these two procedures are specifically for the PySum procedure. So that is the reason why I have put it inside this PySum procedure definition, so that from outside no one can access it. And before closing of PySum procedure, I have called the sum procedure where I'm passing PyTerm as an argument for the term. A value will be whatever A value the user has passed, that same A value will be given over here. Next, what should be the next A should be incremented by. So for that, for informing that, we have defined a procedure called PyNext. So where it is getting incremented by 4. So I just passed the name of the procedure PyNext. And whatever is the B value, the ending value B, whatever the user passes, user shared, that same value will be given over here. So like this, we can define we can define a higher order procedure, and we could use it for multiple summation for multiple other procedures. We can use it instead of having the same steps repeated again and again. If you have defined something like this, something like some higher order procedure, we could use it for different for defining the different procedures. So similarly, if you want to have it use it for the first that is summation of the series, how we could define it, how we could use it. We could define a procedure called a procedure which takes the argument and returns that same argument. So how we can define it? We can define one procedure called um, give some name. Give some name, guys. I'll just type it. For summation of series, if you have to do, sum of numbers. So I'll accept A and B. So what are the supporting procedures which I require here? I require A should be incremented by 1. So since A should be incremented by 1, I have already defined in some cubes procedure. If you see, INC procedure is already defined and it is outside. So I can directly use that. Similarly, if I wanted a procedure which should return the same value, it should accept one value and that same value should be returned back. So how I can define it? So define, I'll give identity, give some variable x, and I have to return that same x value. So x itself, close the definition of the procedure. So once this is done, I can directly call the sum procedure where the term what I am applying can be the name of the procedure term. What should be the name of the procedure? It should accept the same value and it has to return that same thing. So I have defined it under the name of identity. So I can directly write identity. What should be my starting range? It should be the value what the user has given. So whatever user gives for some range of integers, the starting value will be a. So that same a value I'm passing it. What should be my next? Next should be, it should be incremented by one time. So I have already defined INC procedure. So INC, I'm directly sharing the name of the procedure. I'm passing it here. What should be my ending range? What the user gives. Whenever we are calling this some range of integers, whatever the user gives as the ending range, that same value I'm sharing it here. So once the procedure, some procedure is called, the definition of the sum range of integers has been done. So I can close this definition. So I have two things here. One thing is the identity is a procedure which has been defined inside this block. So this identity procedure cannot be used outside this some range of integers procedure. Whereas the INC procedure which is defined outside, so anyone can use it. So I directly use this INC procedure which was already defined. So now with whatever range you are calling it, so if your procedure call is say some range of integers with the values ranging from 3 to 7, we'll be calling the sum procedure with identity. Starting range is 3. What is my next? INC is the next name procedure. B is the value which is there in the 7. So 7 is the ending range. So now it will come to the definition of this part and the execution will happen based on the definition of sum procedure. So where you will compare whether my 3 is greater than 7, condition doesn't satisfy. So it will come to the else part. So where you will be having plus operator applied because it is the procedure is defined for the summation part, where open the bracket, identity will be the name which has been replaced. What will be the a value? A value is 3. So procedure, so once you have put this identity within the parenthesis, then only the procedure call will be happening. The second part of it, it is once again calling the sum procedure where you are passing the values for the arguments. So first argument is identity, the name of the procedure. The second one is we are applying the next procedure, that is INC procedure, onto the value 3. So this is within the parenthesis. That means the procedure call for INC is going to happen. Next is the next procedure, so which is INC itself, this ending range which is 7. So like this it keeps expanding. So first, before the sum procedure is done, we have to get this procedure called INC with respect to 3 has to be done. So where you will be applying the procedure call, n becomes 3. So 3 plus 1, which will return the value to be as 4. So like this, it keeps executing. So once all the procedure call for sum is done, then it starts executing each expression. So I think from here you can complete it. Keeping this with one more example, integral procedure. So whenever we say integral of f with respect to one function a to b, so which is nothing but f of a plus dx by 2 plus f of a plus dx by 2. So it goes on and entire thing will be multiplied by dx. So since this is the summation part, we can use the sum procedure which we have defined. So what are the things which we have to take care now? We need for integral, what are the inputs which we require? We require what function we are applying. So f is required. What is the input a as the range is required. So a and b is required. Along with this, what is the value for dx? So for integral procedure to be defined, we require 4 information from the user. The f for the function a and b within the what is the range, dx for dx value. Now, if you have to execute this part, how we can execute it? So if you see this formula, we are applying a function onto a plus dx by 2. After that, the next content, if you see, f of a plus dx by 2. So the common part a plus dx remains same. The third one, if you see, f of a plus 2 dx by 2. So here also from all these three, it goes on like this. Next it will be a plus 3 dx by 2. So it goes on. If you see the common things from all the three expressions, f of a plus dx by 2 remains same. What about the next part? When you are calculating for the next one, you require just whatever is your a plus dx by 2 plus dx is required. From this second term to third term, when you are doing this content, a plus dx by 2 plus dx is required. So like that it goes on. So you each time you have to keep incrementing with dx value. So now, what is our a value then? That is whatever when we are saying what should be our starting content here, the a part. A part will be nothing but the starting. Whenever we say a range a and b, when we are trying to form it in terms of so that we can use our sum procedure which we have defined it. If we can, if we have to use it, then how we have to reform is we have to make this will be our starting part. So this we have to say it to be as a. So what is our a now? You can say like, which is nothing but, which is plus, that is adding a with dx by 2. So if you wanted your result to be in the floating point part, then you can make your constant or any variable to be as floating variable, floating floating point variable. So how we can make is, we don't have any data type specifically. Only by declaring the variable, that is only when you are initializing it, we can say specify that it is a floating point. So here if you see, we have a constant value 2. So if you make it to be as 2.0, whatever results when you are applying the division operator, whatever result you are going to get, it will be in the floating point. So to starting with this a part, so we have written it to be as a plus dx by 2. That is what we have written it here. So this is our starting content a. So a, we have written it as this expression itself. What is the function for the sum? What is the function which we have to apply? That same function, whatever whether it is sine, cos, whatever function user is passing, that same function we have to apply. So sum of f is our first argument, whatever is the term. Where we have to apply is, we have to apply it onto a plus dx by 2, which is our considered to be as a starting part. So that we have written it to be as a starting a value. What should be our next value? First content we can calculate. When we are calculating it for the next content, what is the extra content? It should be incremented. A should be incremented by how many times? A should be incremented with plus dx. So if you pass this as your a, then we can directly add this content with dx. So for that reason, we have defined a procedure called add dx, where you are accepting the x. So what is this x going to take? X is going to take this part. This entire thing will be our x. So now what we can do? We can directly say this content added with dx. So since it is in the prefix notation, whatever we are writing, so we can write it to be as plus x dx. As a next procedure, we can say that we just have to pass add dx. So name of the procedure, we are just passing it. What about the where we have to stop? We have to stop when it reaches with respect to b part. So when it reaches b, we can it can stop. So is it all over? No. We have entire thing to be multiplied with the dx part. So for that, what we have written is multiplication of this sum, whatever this is returning, that is this part, summation of from this part, whatever this is returning, multiplied by dx value. And then we are closing this integral procedure. So only thing is, what is the term which we are having? What is the starting range? What is the ending range? For if you are having any procedure which is takes the summation part, summation of any numbers, any range of values, then you can directly use this sum procedure. And this sum procedure, whatever we have defined, it is defined with respect to linear recursive process. So for that supporting as a supporting procedures, we can define based on which application you are writing this for. Based on that, you can define the procedure which we have to apply onto each variable, each value. And it should be next content. What should be our next within this given range? What should be our next value? That also can be defined from the user side. It could be generic one, like how we have defined it for increment. Or it could be a specific one, like how we have defined this add dx or pi sum procedure, something like that. So if it is specific, you can make it to be as a block structure. If it is generic, you can define those procedures outside the procedure so that it could be used by all other procedures also, whichever you are defining it within that file. So you are having one practice question. You can, as I said, we have defined the sum procedure in the linear recursive process. The procedure, whatever we have defined, it generates linear recursive process. So now, instead of having it in the linear recursive process, you can generate it in the linear iterative pattern. So you have given some partial code here, saying that the definition of sum, where you are having 4 arguments, the 4 arguments which we have already talked about. And inside this, we are having another procedure, which is considered to be as ITR. That is like a sub procedure, where you are having your A and the result. Can you fill up the remaining parts? Can you try? Immediately after if, what will be the content what you will be having here?
A greater than B, ma'am.
A, that is greater than A, B. If that condition is satisfied, what should happen? This part?
Print result.
It has to return the result. If not, we are calling the same ITR procedure. What should be our first value? What should be the A? What should happen to our A? Second time when you are calling this ITR procedure. What should happen for our A? We should get the next A value. So how do we get the next A value? Say first time when your A, if you are given range of values, sir, say it starts from 2 to 5. A is 2, B is 5. So first time when you have applied, you have checked 2 is greater than 5, condition doesn't satisfy. So it will come to this ITR procedure. Next time when you are calling this ITR procedure, what should be your A value? Should it be same 2?
3, ma'am. Incremented.
It should be incremented. So based on what application you are applying, it should be incremented based on that. So who is going to tell us this A should be incremented by how many times? Incremented or whatever change has to be done? Among these 4 arguments, which one will tell us?
Ma'am.
Next.
Next is going to have the name of the procedure. Next is going to have the name of the procedure, what it has to be done. But if it has to be applied, then we have to write it within the brackets. So it will be nothing but you can write it to be as next. Next, the argument what you are passing is should be A, and then close the bracket. So your first question mark will be nothing but next of A. So it should be within the brackets, that is within the parenthesis. So where you are calling the next procedure, passing this A value and getting the next A value what it should be. Whatever this next function is going to return, that will be taken by this A variable for the next iteration, that is in the next time when it is getting called this procedure, that value will be taken by this A. Coming to the results part, what should be the result applied?
Ma'am, plus term A and result.
Plus
Term A, like inside bracket, and then result.
A within bracket so term A within bracket
And then result, ma'am. Like
and then result. So you have to keep on accumulating each time you call the procedure, you keep accumulating the result. Okay, then close all the procedure. Definition for ITR. First we will be closing this ITR procedure call. Then we are closing the if parenthesis. Then we are closing the definition of ITR. Once you come out of this, we have to call this ITR procedure where what should be the first value? The A. So whatever the user has passed, the starting range of starting value that has to be passed. So A will be the one which we are going to pass. What about the result?
0, ma'am.
It should be 0. Since it is summation part, it should be 0. Okay. So we shall move on. Okay. So now, if you have seen with respect to these procedures, say for example, this add dx, and all, it is specific to this procedure, right? So if suppose if you don't want a name to be given for any procedures, what happens if a name is not given for any procedure? It will not be found in the symbol table, right? So that means next time you cannot use it. That means later on, if you want, you cannot use it. If you wanted it to be specifically used only for this part, that means like only here itself you just want to pass. So you can define a procedure without giving any name. So how we can do is, we can do it by using lambda. So we call it to be as lambda procedure. So lambda procedure means which is nothing but we will not be able to give any name to that particular procedure. So what is the advantage of giving name to a procedure? It is nothing but we have to call it for the next time. We can use it for the next time. But here, if you don't want to give any name, then we can go with lambda procedure. So let's see how the syntax of this lambda procedure is. So lambda procedure, the keyword which we have to use is lambda. So since it is a procedure, everything will be written within the parenthesis. So lambda. Immediately after this, we don't have any name to be given. Directly you can give the arguments. So open the brackets, give the arguments. If you have a single argument, if you have a single argument, we can just give the single argument name. If you are having multiple arguments, give it with a space difference. Say if you are having single argument, you can write it to be as how we have written it like this, lambda open bracket x. If you are having two arguments, say x and y, you can write lambda open bracket x space y, close the bracket. And then comes the body of the procedure. So if you are having, say we have given one example here where we are adding it, incrementing whatever is your x value, that x value is getting incremented by 4 times. So lambda open bracket x, the argument name. That means this procedure is going to have one single argument. Now the body of the procedure. So body of the procedure says plus x4. So everything within bracket. And then we are closing the lambda procedure. Okay. So this is nothing but, say for example, if you are defining a procedure, say plus 4 with x, x plus 4. So it is nothing but, this is how, if you are writing any procedures, the interpreter, how it interprets is, it interprets to be as define the name, whatever you have given, it will be taken to be as lambda of x plus x4. So whenever you are defining a usual procedure like this, by giving a name and all, the interpreter is interpreting it in this way. That is define we are making the name of the whatever name you have given, that is given as given it as the name itself. Outside it, we are having the lambda procedure defined. So that is the reason why we are able to use the same keyword define for your defining the variable as well as the procedure, because the interpreter interprets it in this way. Okay. So the syntax for lambda procedure is everything should be within the brackets because it is the definition of the procedure. So lambda followed by arguments followed by the body of the procedure. So everything should be there within the parenthesis. Okay, so this is what I was trying to explain. So one single example. Say for example, if you have defined a square procedure, so we were defining it like this. So define square multiplication of x with x, right? So that same thing, I can define it like this, lambda of x multiplication of x with x. So definition, I can do it like this. Now, if I have to call the procedure, say square of 5, that means when I have given a name to a procedure, I could call by using the name of the procedure. So which could be retrieved from the symbol table, and whatever is the value, it could be assigned it to the variable argument, whatever has been mentioned. But now when there is no name given, that means it cannot be taken out from the symbol table. So wherever you have defined it, there itself your procedure call should happen. So how we can do is, we can apply it. So where we have defined, the definition of lambda is like this. Definition of lambda is still here. So here itself the procedure call should happen. So call should happen means it is nothing but within the bracket itself, 5. So you can just see here the interpretation. See, we are having the interpreter, how it is interpreting is define. Say plus 4 of x means this is the definition what we are having. So when we are saying define plus 4, this is how the interpreter is interpreting. So if you write the procedure called to be as plus 4, I'm just writing p of say 5. How the interpreter will interpret is, wherever this p is being written, it will be replaced with this lambda part. Right? So it will be nothing but this bracket will be remaining as such. The value will be 5. What this p meant for? P is meant for this lambda of x plus x4. So that will be coming over here. So that means If you are not giving any specific name, so this is how the procedure call should happen. So if you have to apply this value 5, square of 5, your whenever you are calling your procedure, it should be called it in this way. Okay. Clear? One more example. If you are having multiple arguments, lambda, if you are defining the procedure lambda, how we can define is lambda, open bracket, x, y, z. So we are having 3 arguments. And this portion will remain as the body part. So if you see, square is open, square is closed, plus is open, plus is closed. So this becomes the body of the lambda procedure. And then whatever bracket parenthesis we are having, that is nothing but the closing of the lambda procedure. So that means definition of the lambda procedure is closed here. Outside this, we are having one more parenthesis where we are having 1, 2 and 3. So that means it is our procedure call. So x will be assigned with the value 1, y will be assigned with the value 2, z will be assigned with the value 3. And then the definition, then we can have the execution of the procedure done. So it will be nothing but plus 1, 2, square of 3. So square of 3 will be applied, which is 9. Then you will be adding 1 plus 2, which is 3. So 3 plus 9, which is 12. So like this, you will be getting the output. Okay. So the reason for this nameless procedures are, since this Lisp procedure, in Lisp we can have the arguments passed as procedure itself. So it is not necessary that always we should have the name of the procedure given. So what we can have, we can directly give the procedure, definition of the procedure in the as an argument itself. So if you see this same previous example taken out for this pi sum. So in pi sum procedure, where we had this pi term and pi next specifically for this, instead of giving a specific name, what we could do, we could define this part, right? How we could define this part? We can write it to be as only this pi term. If you are saying this, it could be defined to be as lambda of how many arguments we require? We require only one argument. So that we will put within the bracket x, close the bracket. The body of the procedure will be nothing but division of 1.0 multiplication of x with 2, close the parenthesis for multiplication, close the parenthesis for division. We are done with the definition. So lambda is also closed. So this, I don't have to give specific name to this pi term. Instead, I have directly defined it here itself. Similarly, for pi next, this is the content which we have. So I could directly define it to be as lambda of x, lambda of x, where the body of the procedure will be nothing but plus x 4. Body of the procedure is done. So close the parenthesis. Similarly, lambda is also done. So close the lambda procedure. So if you write it in this way, this is nothing but only the definition of the procedure. The execution will not happen. If the execution should happen means we should have an outer parenthesis and you should have the value given here. Values should be given. So how it will happen? So what we can do is we could have rewritten it to be as define pi sum, where we are having 2 arguments taken from the user. I'm directly calling the sum procedure, where instead of writing it to be as pi term, I could directly write this lambda procedure here itself. Whatever we have defined this place, the same thing I could write it here itself. We don't have to write the name of the procedure. We can directly write the lambda procedure here itself. What is our second argument, which is A? Whatever the user has passed, the starting content, that same A we can pass it. What is our third argument, which is next? Next means the definition for next we could define it like this. So lambda of x, which is our this portion. So lambda of x plus x4, lambda procedure is closed. So here we are just giving the definition of the procedure. What is our fourth argument, which is the stopping range? So which is B. So B we have written whatever the user passes, that same B we will be passing it. We have closed the sum procedure. We have closed the definition of your PySum. Okay. So now what will happen? See. So like this, when you are writing it, what happens? First time, when you are having your A is greater than B, condition doesn't satisfy. So it will go to the else part. In the else part, what you are having, we have some summation of it. So plus, then comes whatever, what as a term, what we are having, the term name is nothing but wherever we have used this name term, it will be replaced with this entire lambda part. This entire thing will be replaced at that place. So that means it will be written to be as open bracket was already there. So you will be having one more open bracket, lambda return all the contents till the closing part. 2 and close all the parentheses. You will have 2 and then you are closing all the parentheses with respect to the lambda part. So lambda will have 3 brackets which is getting closed, and then what was your A value, the starting range, if you are saying it to be as 3, so 3 will be applied. So when you are having an outer bracket, that is after the definition of lambda procedure, if you are having the outer brackets and then whatever value you are giving, that value will be taken by this lambda procedure. Then only the procedure call will happen. Similarly, after this we are having the sum procedure getting called. So there your first argument first argument term will remain same. When you are saying it to be as A, which is nothing but next of A. So what is our term next? Next is nothing but this entire thing. So wherever we have used this next, it will be replaced with this part. So this will be written, and since we are having the brackets, this lambda procedure is written within one outer one more parenthesis with the A value. So that becomes your procedure call. So where you will be getting the next A value which has been applied. So just substitute and just try it out. If you are having any doubt, we'll see it in the next class. I'll stop with this. In next class, we'll continue with the substitution model of this lambda and the next content, which is let. So thank you, students.
Thank you.
Thank you.